Hello, my name's Kevin. I'm a musician from London, Ontario. I'm currently in week 6 of the Introduction to Music Production course at Berklee. Today I'm going to be talking about the 5 most important modules of synthesis. The creation of a waveform or a sound begins with the oscillator. There are quite a few different types of oscillators. The most common one used in music is the voltage-controlled oscillator. And this you usually find in a synthesizer. Using filters, it actually creates various sounds, and they're all built up from very base waveforms like sine waves and sawtooths and square waves. The sound produced by an oscillator is usually quite bright and aggressive. Even the simpler waveforms can be used all through music, and there are all sorts of qualities of timbre that can be achieved, giving you lots of voices on a keyboard to choose from. An oscillator is basically a generator of audio, and it delivers it at a specific frequency and amplitude. When you hit the key of an electric piano, it's a simple on-off event. It goes on and achieves a certain amplitude and frequency, and then it turns off. And that is your audible sample. Synthesized oscillators use modulation, and this allows changes in pitch and frequency over time. Filters are otherwise known as voltage-controlled filters. Filter acts like an oscillator in that it modulates, setting cutoff frequencies and dealing with resonance. In a recording studio, the most important filter is the 24 decibel low pass filter. This is used to drastically reduce the high ends produced by the oscillator. There are many filters that help in shaping the spectrum of sound. Because the oscillator produces such bright, sharp sounds, we need these filters to calm them down and remove the high end. The low pass filter is the most important because it is what determines the amount of bottom end and substance that we hear. Dynamic filter effects allow you to manipulate waveforms in quite a variety of ways, allowing you to be quite creative with it. The amplifier, otherwise known as the voltage-controlled amplifier, deals with the volume over time. Again, it uses modulation and sets the path of a note or a wave using 4 basic parameters: attack time, decay time, sustain level, and release time. So when a sample gets amplified, it is first addressed by the ADSR envelope and the low frequency oscillator modulation, and then sent to the voltage controlled filters, where it is again addressed by the ADSR and the low frequency oscillator. An envelope is a set path of time and value levels that are applied, and they help in shaping signals. Using ADSR, we can shape how a note event will happen. When we hear a note on a piano or a guitar, we hear a note initially goes up to some value and then eventually falls to nothing. And this follows a pattern that is characteristic of a particular instrument. So the volume pattern of any note played on any instrument is known as volume envelope. LFO stands for low frequency oscillator. It's used to apply modulation effects like tremolo and vibrato. Quite often a synthesizer will have a wheel that controls this. The LFO deals with sounds that are below the human hearing range, usually anywhere from 0 to 20 hertz. This concludes my demonstration, and I appreciate you all having a look, and I will see you next time.